We're going live.
There you go. Good evening, DevOps boot campers. So today is a little unusual. Today we're doing a spring term review, and as I'm sure you know, we are not actually in Corvallis. The three of us are here today in Portland, Oregon. We are actually doing this via Google Hangouts because we are at a talk on technical writing, or rather, we're at a conference on technical writing. So technical writing is a really crucial skill, and you will be doing a lot of technical writing throughout your career in order to document your code for users, fellow developers, and even your future self. You'll learn more about this in Writing 327, which is a technical writing class. However, today in DevOps Bootcamp, we're going to talk about what we've covered this year in this spring term, which is configuration management, continuous integration, web application frameworks, testing and development, and finally Docker. All right, Lucy's up next with configuration management.
All right, guys. So this is just a review, so it's all stuff you've heard before, but just to go over it again. So if you guys will remember, configuration management is the automation of tasks that you do very repetitively. So things like updating your machines, or maybe installing packages, making sure everything looks the same. All of that is kind of what configuration management is about. It's also centralized so that your entire team can work together and be working with the same tools. It's standardized so that all the same tools are being used. And it also provides some history, kind of like GitHub in terms of version control. There's a couple different major configuration management platforms. One of them is CF Engine, so that was kind of the OG of configuration management. The two big ones currently are Puppet and Chef, which if you ever work with configuration management, at least in the next few years, that's probably what you'll be working with. And then Ansible is another kind of up-and-coming player in the configuration management game. So kind of like I just said, CF Engine, the OG, it's lightweight. It manages the configuration of a large number of computers. Puppet, on the other hand, actually has its own declarative language. That's kind of what makes it really unique. And it distributes its data using a client-server paradigm, which we might cover later. Chef is a configuration management tool that is written in Ruby, and it uses a Ruby-based domain-specific language, or DSL, for writing recipes, which are kind of its version of the documents that you write in order to actually perform configuration management. And just like Puppet, it uses the client-server model. And then Ansible combines multi-node deployment and ad hoc task execution and configuration management all in one package. And it utilizes SSH, which is kind of what makes it really, really cool. So it has little to no remote agents. Configuration management includes things like system-wide settings, so any environment variables you have, SSHD, LDAP, things like that. Any group settings you have, standardizes global settings, and it also makes it easier to troubleshoot. CF Engine, it's really good at scaling, so if you have a really, really large data center, it might be a good thing for you, but it is not very agile, so it's not very good at changing on the fly. Yeah, that's a good way of phrasing it. Puppet uses a lot of dependencies and figures what order to run them in. And the Puppet domain-specific language can sometimes present a little bit of a learning curve, which can be an issue, and it also has some issues in terms of scaling. Chef executes the commands and the scripts as they are listed within minimal amount of dependencies, which makes it pretty lightweight and easy to use, and means it usually works out of the box. Using Ruby offers advantages and disadvantages, because if you already know Ruby, you don't have to learn a whole new language. But at the same time, Ruby can present some problems, especially since it stops being supported. Each version stops being supported after just 1 year. So every platform kind of has its pros and cons. And with that, I will turn it over to Ian.
So continuous integration is we're going to see a common theme here. We're going to take the stuff which is boring to do, like configure servers and run tests, and we're going to automate it so it'll be easy to do and repeatable, and it'll take a lot of load off of ourselves, the programmers, or system administrators. So development tends to follow the same pattern. First, you write the code, you write some tests to go along with the code, and then you run the tests, and if all the tests pass, then you put it up for review. And then you might have to test not just your code, but all the other code and see that all the code works together is really well integrated and passes integration tests. And if all the tests pass, you package your code, maybe in a tarball, or maybe you make a Debian package, or maybe a Python package, and so you upload it to the Ubuntu repositories or the Python repositories so other people can pull it down. And once you're done with that, you go on and start up again and write new code and new features. Now, there's this kind of repetitive and difficult part, which is running the tests and packaging your code. And in and of itself, it's not that difficult, but doing it repeatedly is kind of a painful process. So that's why we have continuous integration. So we're going to have the robots run our tests and package our code for us. So there's 4 common continuous integration platforms out there today. There's BuildBot, Travis CI, Drone, and Jenkins. BuildBot is very stable. It's excellent for large projects. Travis is very small. It's a startup which basically lives off of its integration with GitHub. There's Drone, which aims to extend what Travis has done and add a lot more flexibility. And there's Jenkins, which will run anything you tell it to. We'll go into all of these in more detail. BuildBot is most important for the largest projects. Chromium is a great example. Chromium is kind of the open source version of Chrome. Chrome is extracted from Chromium. It's basically a version of Chromium. And so to write, in order to run tests for Chromium, people have written Python scripts, which run all of the tests written in C++ and Python, and it tests all of the functionality of Chromium. So first you have to test that your rendering engine works, and then you have to test that your JavaScript engine works. So now you've tested HTML and CSS and JavaScript. Now you have to test them both together. And these test runners can get horribly complicated, and then we have to do it on like 12 different platforms, all sorts of versions of Linux, 5 different versions of OS X, Linux on 2 different architectures, Windows on 2 different architectures. It's going to get complicated. And so BuildBot's real flexibility is BuildBot's real advantage is its flexibility, is that you can write arbitrary code in order to run your tests in a wide variety of platforms and a wide variety of situations. It's also horribly complex to manage. You need a lot of experience in order to get good at BuildBot. Travis CI is the opposite of BuildBot. It is so easy. You just write up this very simple configuration file, stick it in your GitHub repo, sign into Travis CI, and flick a switch, and all of a sudden, every time you push new code to GitHub, it will test that your code is working and report back to GitHub whether or not your build you're failing or passing, whether or not your tests are passing. And so here you can see an example build of the Genetic Web Manager project, which I was working on yesterday, and it's broken right now because not all of our tests are passing today. And so we need to fix this. And so every time we look at our GitHub repo, there's this little red button which says that our build is failing, and so we need to go fix this. Its integration with GitHub is what makes it amazing. It is so simple to write, so simple to run your tests, and it all happens on someone else's machine, and it also displays the status of your builds to the world, so they can see whether or not your software is really reliable, whether it's well tested, and whether all of the tests pass. Travis has some limitations, which we'll go over in a little bit. Jenkins is also a really cool project. It'll do whatever you want. Basically, you take this Jenkins application, which is a Java jar file, so it's basically a big old platform-independent executable. You spin it up on your machine, and you can give it permissions to SSH to all of the hosts in your data center and run all sorts of things. You create jobs using a web UI, which is different than Travis, which uses a config file, and BuildBot, which uses Python scripts. And so Jenkins is great because it can do literally anything you want. But Jenkins isn't the best because its disadvantage is that it's not very ephemeral in the way the Travis is. With Jenkins, when you don't necessarily have an easy way to edit jobs without a web UI. Your jobs are not under configuration management, which is this huge. I'm sure you've seen by now how important configuration management is to DevOps. It is the cornerstone of DevOps, really, and you don't have that with Jenkins. However, Jenkins' great flexibility is what makes it very useful. It's easy to use by people who don't necessarily have the skill or understanding to go in with a text editor and also edit and all sorts of complicated config files. Drone is kind of a reaction to Travis's limitations. Drone has this idea that instead of running, Travis only runs your tests on one platform, which is Ubuntu. And so a Drone allows you to upload an arbitrary Docker file, and it will run your tests in the resulting Docker container. And so it takes your tests and your Docker file, builds a Docker image, and it just goes. So with that, Eli here is going to tell you a little bit about web application frameworks.
Hello, my name is Elijah. You all know me from class in MeetSpace, and if you don't know me from class in MeetSpace, that means you're probably using the online curriculum, and thank you. Please give us feedback on that. So as far as web application frameworks go, I'm just going to do a quick summary of the material that we covered. When I cover web application frameworks and testing, just keep in mind that this is just a cursory overview, just sort of to try to jog your memory, so to speak. If you want more details, though, go back to our curriculum and look at the web application frameworks and the testing week. I think that we have a video on testing and slides on web application frameworks, as well as slides on testing. So anyway, what is a framework? Let's just ask that first question just to actually get started. Essentially, a framework is kind of akin to a library. It's just a set of tools that takes care of a lot of things for you. So the slides say that a framework is a piece of software that provides generic functionality that can be selectively changed by additional user-written code, thus providing application-specific software. And this sort of means, like, with a Django app, with a Python framework, you have a set of tools at your disposal that you can access with Python to create something new, like a Django web application or a Flask web application. So specifically, though, web application, not to jump ahead of myself, is a framework that provides many useful tools and universal functionalities so that you don't have to worry about them. Sorry for reading off the slides, but it's just it's the best way I can think to say it. And this basically means that it provides a lot of tools like URL forwarding and security problems, and basically means that you don't have to reinvent the wheel, like the slide says, every time you make a web app. You don't need to start with some networking library and build from there. It also gives you safeguards, and it gives you the added bonus of the fact that you're using a set of tools and libraries that are tested by a community, and in theory are a lot stronger than anything you would write. Not that you're not that you're a bad coder, but it just happens. When hundreds and thousands of people use something, it becomes much stronger as a piece of code and a set of tools. So popular frameworks include Django and Flask. Django is sort of like the behemoth of web application frameworks for Python. Flask is much more lightweight. Anything you do with Flask, you're gonna build yourself, like an admin interface and anything like that. Django comes with that a lot of that pre-baked. On the Ruby end, there's Rails and Sinatra. Rails is sort of like Django, and Sinatra is sort of like Flask. It's sort of the Ruby. Those are sort of the Ruby analogs, so to speak. And if you're into writing JavaScript on the server side, as well as the web browser side, Express, Koa, and Happy are all things that you should definitely look at, because they're pretty reputable tools and are just as well tested as Rails, Sinatra, Django, and Flask. Most frameworks come with things like object relational mappers, which are really useful for interfacing with a database. They also include migration tools, which are an arduous process without interfaces like this. And we'll get into what these are in a second. And also templating engines, which I would look at the slides for more information on this, but essentially it turns your HTML into a Mad Libs, where you get to insert information in the form of variables and render a page based on those variables. So a model is sort of like you can think of it as like a programming language object, so like a Python object. But instead of it just having functions and variables, it's actually a way for you to interface with the database. So Django, for instance, has a really good database model system, as you can see here, where you're creating a person class, and that person has a first name and a last name, and this is actually accessible in an API as a this can be accessed through Django through the Django database interface, which is super convenient. If you're interested in this, look at our slides and also look at the Django documentation. And models aren't unique to Django. They exist for most frameworks, but Django is just something that we're very used to, and these principles do translate. But these examples tend to be mostly Pythonic in nature. So that's cool. Oh, I guess I skipped the slide about data migration. So one thing that I should point out before we move on to templating is migration is essentially the idea of, say you have a social network and you're not keeping track of people's pets, but all of a sudden you want to. The way that databases work, you can't just add that field. You actually have to do something called a migration, where you create a separate database that has the pets field, for instance, and you run a migration, which is basically mapping the data on your old database onto the new database. So you translate from the old database the name, the age, the height of the person onto the new database, and then you have some default value or some user submitted value for pets. So you can't just add a field to a database. You actually have to do something called migration. And a lot of these tools include migration out of the box, which is super convenient. And like I said, this is Django, but these apply anywhere. So templating engines, like I said, are sort of like Mad Libs, but you can also do cool things like functionality. So the example here, this is Jinja, which is a Python templating engine. Jinja can do something like you can send your template a list, and you can have a for loop that iterates through the list that was given to it. And then for each item in the list, say it's a dict of dicts, it can iterate through each item in the list, and it can say, okay, well, for this item, print out the, say it's a set of band names. You can print out the band name and when it was founded or something like that. And here we have navigation, and it's iterating through that and creating a list of navigation menus, but it can be used for tons and tons of things. Another example I like is how does Facebook know to put your name on your page? Well, it uses a template, and when it renders your page, it doesn't just have that statically lying around. When it creates your page on the fly, it sends your name, it processes all the information about you, sends your name, your date of birth, all that stuff, and sends that to their templating engine, and it generates a piece of HTML or PHP with your name in place of user.name. So if that doesn't make sense, go back to the other slides and it'll make a lot more sense. So moving on to testing, this was talked about a little bit with continuous integration, but essentially testing is a way of automating what most of us might do by hand. So you're writing a program for your class and you have to make sure that, say it's a calculator, you have to make sure that it works. So you start it up, you add two numbers together, you add three numbers together, you subtract, you multiply, divide, etc. Do some modulus arithmetic. This is very arduous and takes a really long time for us as people to do this, but these are mostly just things that we can just automate. So what we do is we write tests that automate the testing of a set of functions or a program, and so that's very, very useful, and it also gives us these advantages too. Make sure it makes you, if we write our tests before our code, then we've written a set of tests that we need to meet the qualification for. So essentially what you're doing is you're making sure that the product you're making actually meets the requirements you need, and it sort of forces you to contemplate what you want to make or what you need to make. So there's two types of testing that are very popular. There's static versus dynamic. Static, basically, it's sort of like if someone looked at your code and told you what's probably broken about it, and dynamic is actually running your code. So dynamic takes a lot longer, but it's a lot more thorough and more accurate. Static is much quicker, but gives you some pretty good advice overall. And there's some other paradigms. One is black box versus white box. White box testing tests the internal structure. And black box, white box assumes that you know what functions exist, how they work, etc. But black box testing sort of is like testing how it should work. Basically, you're saying, well, this function, this method should work like this. So you test how you sort of expect the functionality to happen instead of testing how you know it happens. And this is very useful for maybe testing some code that you didn't write, or you're testing some client's code that you don't really care how it gets done. You just want to make sure that the things that you want to get done do get done correctly. So there's other types of testing, as I mentioned, sort of hinting at. There's something called unit testing, which is where you test each individual part. So say you have 10 functions, you test each of those functions individually. That's unit testing. Integration testing is testing how everything sort of works together, how things interact with each other. So maybe one function needs the output of another function. Unit testing would just be testing those individually, giving them more or less expected output. Integration testing is testing actually taking the output of one function and giving it to another. So you're sort of, it's almost like interaction testing. And then system testing is the last thing you'll do. It's essentially testing everything and how it all works together. This is almost like almost akin to deploying your application, but automating that process. So testing frameworks are really useful. You could write your own functions by hand that just sort of shoehorn this functionality in, but most popular programming languages already just include something out of the box. Python includes, you don't even need to download it through pip or the package manager. You can just include unit test, and that'll give you a unit testing framework. So this is an example of a unit test. This is sort of pseudocode at the top, and then at the bottom there's something more akin to an actual test. You basically import from unit test, import test case, and then you say something along the lines of self.assert true or self.assert false. And that's basically saying, I think that this statement inside these parentheses will be true, and if they are true, then the test passes. And if you say I think that the statement in here is going to be false, then if it results to false, then the test passes as well. So it's sort of, the test passes if your assertion is correct. If that makes sense. I hope that makes sense in a broad way. So another method of testing would be mocking out functions. So this is very popular. So say you have a networking library that needs to interface, and it needs to do some mock calling. So say you have an API that you call, and you don't want to make sure that the API is up and running every time you run your tests. You do something called mocking, where you basically fake it. And this is very useful for just guaranteeing that you can always run your tests without having to depend on some external system. Tests commonly should be able to run on their own. So this is sort of an example of mocking. This is written in Python as well. Basically, you're just faking what the response of this will be. And this is some more mocking. Sorry, I'm not able to explain this too much, but this is sort of what you're going to be looking at if you're mocking some functions. So then one last thing before we move on to Docker with Ian is the idea of setup and teardown. So say you're testing something that involves a database that has to have something in the database. Your tests will need to make sure that the database interfacing works and everything works as expected, including the database parts. So you have to set up a database and tear down a database. This is part of testing, but it isn't explicitly a test. So this is just something to keep in mind is when you're creating a test, you can't just test a function. You have to test and make sure that everything the function expects to exist does exist. So, hey Ian. So now, without further ado, Ian is going to help us out with some Docker stuff, Docker review. Thank you.
All right, so Docker is based on this idea of containers. So what are containers? That's the first most important thing right here. Containers are not virtual machines, but they accomplish some of the same things. Containers are a way to put a program inside an imaginary box where it thinks it's the only program running. And how do we do this? Well, we basically just change the OS. We rewrite our OS so that when we set things up properly, our OS will lie to the program running inside the container, so it thinks that it's the only program running. And so containers are great because they are fast. They don't have the same overhead which virtual machines have. However, both the blessing and the curse of containers is that the way they're typically used, every application is running within its own container. So this changes the way you have to configure your application, because if the two parts of an application think they're running on different machines, well, they have to talk to each other somehow. And you typically do that using like HTTP. You just make them pretend they're talking to each other over the internet, or via Unix sockets. That's the other way we do it. So Docker is a tool to take advantage of the power of containers. And so it also gives you a way to reproducibly build your images. The bits and pieces which make up your application can be put together in a reproducible manner. So if I do it on my machine and you do it on your machine, we will get the same thing out. I mentioned, and I'm going to mention it again, each part of the application runs inside of its own container. Your database, your web app, those are going to be in different containers, and they're going to talk over probably a Unix socket. The caching layer, like Redis or RabbitMQ, same thing. The Redis is going to think it's in a different application, a different computer than system view. So before we go on, we need to talk about some of the terminology we've used to describe Docker. Docker has this idea of an image. An image is the collection of files and programs which make up your application. It's just like a VM image. The great thing about images is that they can be stacked on top of each other. They're called layers sometimes. And so you can have, you can inherit from other images the same way you inherit from classes. You get to reuse all of the files in the other image in your new image. Now, once you have an image, you can start up the program within the image and make a container. And so the container is, an object, in our analogy, where we have the image as the class, the container is now the object. And so the containers here are just Docker running the application in the image inside a Linux container. Finally, we have this idea of a Docker file. And a Docker file describes the steps necessary in order to build a Docker image. So I'm going to go over briefly some common things you do to get started with Docker. So one thing you might do is you might pull down an image. And so images are all stored, not all of them, but some of them are stored in a website called Docker Hub. And so when you type docker pull MySQL, by default, the Docker program goes out to Docker Hub and asks for the MySQL image, and then it downloads it. So once you have the image, you can now run it, and you can start up a database. So you type docker run-d, all that stuff, you can see it right there on the screen. I'm not going to recite it for you, but I'll explain the parts to you. So once we have this image, we can run it and get a container. The -d flag here means that it will run in the background. The ~name flag means that you're giving your container a special name. And if you don't give it a special name, don't worry, one will be chosen for you. And then the -e flag allows you to set environment variables. And then finally, you have the name of the image which you're starting up, the image which you're running. And so once you run this command, you will have a Docker container running named MySQL container. So now that we have this container running, we might want to go in and add stuff to the database or run bash and see kind of the state of MySQL and what MySQL is doing. So we can use this docker exec command. So it'll execute bash. The -it flags mean that it is an interactive session. If you don't pass the -it flags, it will go ahead and run bash and say, yep, bash exited. And you go, well, great, I didn't get to do much there. And so you can also run the MySQL program within the MySQL container. And so that -p flag is being passed to the MySQL program and telling the MySQL program that you would like to enter a password. Then once the MySQL program starts up within that container, then you can start manipulating the database and seeing what's in there, select star from table, all that stuff from the databases lesson. So I described how Docker images are built from Docker files. Let's take a look at a sample of a Docker file. What I did was I took the MySQL Docker file and I made it a little more simple, but the core functionality is 100% the same. So first you start off by inheriting from another image. You start with the Debian Wheezy image. So Wheezy is a version of Debian, and Debian's a Linux distribution. And then you run these group add and user add commands, which you might recognize from, some of the very first lessons. It might have been like the third lesson where we talked about users and groups. So here we are as we're creating a MySQL group and a MySQL user. Then we have to upgrade the operating system and install the MySQL server, set up some useful environment variables, expose a port to the host machine, the machine which is running the container, so that you can talk over that port to the MySQL program running inside the container. And then finally, the program which is run at the very end to run the actual database, and that's MySQL D, the MySQL daemon. So once again, from inherits from a parent image, run just runs an arbitrary command, env sets an environment variable, exposes a port to the world, and command is the final command to start once the Docker file is kind of done executing, and once the container starts up. So with that was spring term at lightning speed. And we didn't want to keep you for too long. There's a whole lot there, and I encourage you to review these slides, and more importantly, review slides from previous lessons. Feel free to review all the slides from previous terms. There's a lot here. I think we have taught you a whole lot of things. You might not understand everything today, but we have given you the exposure so that when you see Docker again, when you see Travis CI, you'll know, oh, I know roughly what Travis CI is, and so I can go read the Travis CI docs and make my application use Travis CI or what have you. So thank you so much, and that's it. I hope you have a good evening.
Closing the doors at 6 o'clock. It's 5:40, so you got about 20 minutes before we have to kick you out. Please come back tomorrow.
It's stopping.
Okay.